Hey everyone, my name is Rachel Edgel, and for topical presentation one, my topic is quantitative reverse transcription PCR or polymerase chain reaction, also known as Rt-qPCR. So what Rt-qPCR is it's actually the reverse transcription of an RNA strand or an mRNA strand to produce complementary strands of DNA. So first what happens is you have your mRNA or your RNA strand that normally starts with your AUG or your start codon, and it usually finishes with a poly A tail. So as you can see here, the pink represents adenine, and so you have a lot of A's. In order. So after that, a complementary strand of DNA is then formed, as you can see, matching up with their respective bases. So adenine matching up with thymine, uracil matching up with adenine, guanine matching up with cytosine, cytosine matching up with guanine. And so then the strand is actually taken a step further to where the amplification of DNA happens, and you're going to get that double helix shape of complementary DNA. So, an RNA sample is normally most commonly taken through a nasopharyngeal swab, which is, as you can see here, where the nasal passage and the pharynx passage actually meet. An example of this would be a coronavirus test. As you hear, a lot of people says it hurts really bad and it makes sure your eyes water, and it's because of it has to go further in to the passageway rather than like a normal flu test. So RT-qPCR can actually be carried out in two different ways. So one step or two step. So one step is where the reverse transcription of the RNA and the amplification of the complementary DNA happen in one process. So reverse transcriptase and DNA polymerase being combined to finish out this process. Two-step RT-qPCR is where it's actually kind of broken up. So first you have the transcription of the RNA, and then secondly, you have the conversion or the amplification of the double helix DNA. They both have their advantages and disadvantages. One of the major advantages of one step would be the fact that it's very fast and it only happens in one process, so there's a less likelihood of contamination. But a major disadvantage of it is the complementary DNA cannot be stored, so it cannot be saved or used for a later date to examine it months down the line. On the other hand, one of the major advantages of two-step is the fact that that complementary DNA strand actually can be saved. But a major disadvantage of that is the fact that it happens in two processes, and um, it takes a little bit longer, and there's more likelihood of contamination. So it can actually be used for many different things. One thing that's kind of relevant to us now more than it kind of has ever been is since the coronavirus pandemic. So pathogen detection or disease research. So RT-qPCR can actually pick up the genetic markers of the coronavirus. I think it's as little as like 1,000 copies per milliliter. So even if there was a very little amount of genetic information for the coronavirus, then it can still be detected. Another thing is gene expression analysis. So the way that your body synthesizes RNA and proteins, and then genetic testing. So we have a lot of disorders that are genetic, such as Alzheimer's, breast cancer, things like that. And the specific genes that code for those disorders can actually be mapped, known as genome mapping. So the graph you see here, so you have a threshold. Anything that falls below the threshold is going to be a negative result, as if you're talking about a disease or a pathogen detection, and then anything above it would be a positive result. When you're talking about genes, anything that falls below the threshold is a very unlikely chance that that person is going to develop that disorder. And then anything above that threshold is going to be very likely that that person is going to develop that disorder. So, as you can see here, the gene A or the black dots being that really high curve, more likely that this person is going to develop whatever disorder gene A codes for rather than B and C. So that is my presentation on reverse transcription PCR.